Hello students, welcome back to the channel. So in this video we are going to be proceeding with our topic, which was trigonometry. So in this video we are going to be looking at something which is basic but at the same time very important as applied to pure mathematics. So we are going to be looking at trigonometric graphs, how they are sketched and what they mean, and then later we look at how we can obtain different angles of sine together with tan and cos. So the video is presented to you by Olga Yusuf, and the advice to like the video, subscribe to the channel, and then share the video to your colleagues. Let's begin. So first we are going to start by sketching the trigonometric function graphs, and we are going to be looking at what each of them means. So if you look at the graph of sine x, again it's every value of x, and x is going to be in terms of angles. So this wasn't supposed to be cos x, but it was supposed to be sin x. So sin x is going to be on our y-axis, and then x, which is going to be the angle, is going to be on our x-axis. So this graph is telling you that at negative 360, the value of our sine is going to be 0. That's why the sketch started from there. And according to this graph, you can see that from this graph, the maximum value that we attained is positive 1. And also the minimum value that we attained at different angles is negative 1. So this means that whenever you're having any value of sine, let me say sine theta, any answer of sine theta should be lying between negative 1 together with positive 1. So if at all you're having any value of sine theta which is greater than positive 1, we shall be saying that theta for that case is going to be undefined. And if at all you're having a value which is lesser than negative 1, for example negative 1.2 or negative 2, we are going to say that also for that angle theta is also going to be undefined. And you're going to be looking at that in examples. So this graph is basically showing you that the maximum value of sine x or sine theta is going to be positive 1, and the minimum value of sine theta is also going to be negative 1. So anything lying beyond this range, we are going to say that that angle is going to be undefined, simply because it doesn't qualify for the conditions of sine x to be true on its graph. So if you look at the graph of cos x, it's going to be basically of the same kind like that of sine. Also for cos x, the maximum value is going to be positive 1, and then the minimum value is going to be negative 1. And this is showing you that whenever you see the curve touching the x-axis, it's telling you that when the value of x is negative 90 degrees or positive 90 degrees, the expressions are going to remain, the value of cos x is going to be 0. And if you look at this graph, negative 90 is 0, and also positive 90 is 0. Similarly, negative 270 is 0, and also positive 270 is 0. So for this case, we are going to see a term showing you that for any value of cos of a negative angle is going to be the same as cos of a positive angle. So that's what this graph means. If you put cos negative 270, you're going to get the same answer as you put cos of positive 270. And similarly, if you put cos of negative 180, you're going to get the same answer when you put cos of positive 180. So for cos of a negative angle is the same as cos of a positive angle. And you have said that just like sine, also the maximum value of cos x must be not exceeding positive 1, and it must not go below negative 1. So that means that any value which exceeds that, any value of cos x which exceeds that, we are going to count the angle to be undefined, simply because it doesn't lie within our limits. Now if you take a look at the graph of tan, the graph of tan is quite complicated, but what you have to explain is going to be these vertical lines. So on these vertical lines, if you put tan of negative 270, you are going to get math error. And that's showing you that that angle at that point, or at that particular angle, the tan of that partial angle is going to be undefined. So when you're making your answers, in case you're having these angles where you have put our dotted lines, we simply say that the value of theta or the value of any angle, either theta or x, is going to be undefined. But you're going to look at these main details. Now let's proceed at the real field. Now if you look at the previous video, as we are getting the different trigonometric ratios for sine, cos and tangent, you saw that we are using some of these terms. So these ones are called other trigonometrical functions. So sec, in the first video, remember that we said that sec theta is going to be the same as the reciprocal of cos. So sec theta is going to be the same as 1 out of cos theta. Then cosec theta is going to be the same as 1 divided by sine theta. And then cot theta is going to be the reciprocal of tan. So it's going to be 1 divided by tan theta. Now having looked at that, let's look at how we can relate both radians together with degrees. So we're going to say that angles can be measured in either degrees or radians. So the relationship between radians and degrees is going to be that 1 pi is going to be equal to 180 degrees. So now we are going to be looking at how we can convert degrees into radians and how we can convert radians into degrees. By that expression, simply by saying 1 rad is equal to 180 degrees. So for that, we are going to quote our expression that we are always going to be using. Now this is going to be one-sided because during the calculations, your calculator is going to be in degrees. So if at all the question requires an answer or the item requires or tasks you to find the angle in radians or the range given is in radians, you have to convert that answer that you have got from your calculator into radians. And you're going to use an expression that 1 rad, which is the same as pi, is going to be equal to 180 degrees. So now we get how many radians are going to be in 1 degrees simply by dividing through by 180. So when you do that, we are going to come up with 1 degree to be the same as pi divided by 180 radians, which can be abbreviated as rad. So that means that we can find other angles. If you're having 15, 45 degrees, 75 degrees, what are they going to be in terms of radians? So 15 degrees, you simply get this and then you multiply it with a particular angle by eliminating the degrees. So it's going to be 15 times pi divided by 180. And if you divide 15 by 180, you're going to end up with 12. So that's why we end up with pi divided by 12 radians, or rad. And then 45 degrees is going to be the same as 45 times pi divided by 180. But if you divide 45 by 180, you're going to get 4. So we end up with pi over 4 radians. And this is a special angle. So it means that you must be memorizing it both in degrees and also in radians. So 45 degrees is going to be the same. So when we divide, so you need to understand that you need to, these are special angles. 45 degrees, you need to know it's a special angle both in degrees and also in radians. So 45 as a special angle in degrees or in radians is going to be the same as pi over 4. And you need to always memorize that. Now if you go to 30 degrees, remember that it's also a special angle. In the previous video, we said that we're having 3 special angles. We have 45 degrees, we have 30 degrees, we also have 60 degrees. So that degrees, to convert it into radians, we simply get it and then we multiply it by pi divided by 180. So you're going to get pi divided by 6 radians. So also 60 degrees, we do the same, 60 times pi over 180. So if you divide 60 by 180, you're going to get 3. So 60 degrees in terms of radians is going to be pi divided by 3 radians, or rad. So you also do the same procedure to convert 90 degrees into radians, which is going to be the same as pi over 2. And that's how we convert angles in degrees into their corresponding angles in radians or in small angles. Now let's look at the basic trigonometrical equations and now we can calculate them. Now remember, in the previous video we said that we measure positive angles going in the anticlockwise direction. And I say that to do that, we consider a range which has only positive angles. So if you look at this range, it says that theta is ranging from 0 degrees to 360 degrees. So that means that for that, when we are getting angles under this range, we should measure our angles starting from the positive x-axis going anticlockwise. That's how we measure angles of positive ranges. But again, if you look at this range, we are having a negative 180 degrees to positive 180 degrees. So since we're having a negative range, that means that we are supposed to measure negative angles. And to measure negative angles, we start from the positive x-axis and then we move in the clockwise direction. So always remember that. So now let's look at the given examples by which we can exercise what we have studied. So for this, to do that, first we made a brief written step by step of which you can usually refer back or refer to in order to understand the steps that you're going to go through in this video. But all this video is going to be centered on how we are going to find different angles on different ranges. So if you look at this, we are having positive ranges. That means that you are going to be measuring angles starting from the positive x-axis going anti-clockwise. So for the first step, we are saying that to solve a basic trigonometric equation such as sine theta to be equal to a given constant, the following steps are going to be followed. So first we are going to first find the quadrant for which the angle is going to be lying. And you are going to find the angle simply by taking sine on this side. Now when sine crosses the equal sign, it becomes arcsine. On your calculator you have to press shift and then you press the sine button to get this symbol. So it's going to be arcsine of the constant that you had this side. So you are putting a modulus sign towards this k simply because when you're getting an angle, your answer must not be a negative, but you're going to explain that in details. So step 2, we are going to identify the quadrant in which our angle is going to be lying. So the angle, we are going to denote it by theta. So for this, let me first try to remind you about that. So in the previous video, remember this video is a series, so to understand properly, you need to have followed from the first point. From the first video, we said that all angles here are going to be positive, and this quadrant, sine, tan, together with cos, are all positive. And then we said that in this region, it's only sine angles that are going to be positive, and others are going to be negative. And then we say that for the third quadrant, it's only angles of tan that are going to be positive and others are going to be negative. And then we say that in the fourth quadrant, it's only cos that is going to be positive and others are going to be negative. So after finding your angle, you are going to get the first angle to be lying in the first quadrant. Then for us to get the other angle, we are going to determine a quadrant which has a positive angle of that kind. But don't worry, we are going to look at that in details by these examples. So step 3 is going to determine the corresponding angles which are present in those quadrants. So now let's look at the worked examples. So example 1 or question 1, we are supposed to find the angles if at all sine theta is equal to positive 0.3814. We also find an angle where cos theta is the same as 0.667. We also find an angle theta where tan theta is equal to 0.5733. Now the most important thing to note here is that we are given a positive range. So if at all you're having a positive range, you should know that we are measuring an angle starting from the positive x-axis going anti-clockwise. And since every value here is positive, that means that sine theta, we are getting an angle from a region of sine theta where sine is positive. simply because they use sine to be positive. So it's going to be, remember that the first angle you're going to get is always going to be coming from this region in the first quadrant. Then the other angle is going to be coming from the region where the given value or the given trig expression is either positive or negative. But for this case, our sine theta is positive. That means that we're going to the quadrant of sine, which is positive, and then we get the second angle. So now let's look at the first solution. So the first solution, you are given that sine theta is equal to 0.3814. And then the first quadrant angle, to get the first quadrant angle, we simply just take sine onto this side. So it's going to be arc sine, or what you can call inverse sine, but you're going to be using arc sine. So it's going to be arc sine of 0.3814. So you get your calculator and then you press this expression the way it is. And then angles must be to 2 decimal places strictly. So the angle which is going to lie in the first quadrant is going to be 22.42 degrees. But remember, after you get in the angle, we say that the first angle is always going to be lying in the first quadrant. In the first quadrant, all trig identities are positive. But now after getting that, now you refer back to the given expression. If you look at our given expression, you are given that sine theta is equal to positive 0.3814. Now we have to go back to our quadrant. We have already got the angle here, which is 22.42. So you also have to get the second angle where sine is positive, because according to this expression, the value of sine theta is positive. So to get the second angle, we go to the second quadrant where sine lies, or where sine is positive. And then we measure our angle starting from the positive x-axis going to that specific quadrant. So let's look at a given sketch for that. So if you look at this sketch, angle theta, the first angle that we got was 22 degrees, 22.42 degrees. But we say that also sine theta is positive in the second quadrant. So we measure an angle from here to the second quadrant. Now notice, according to the properties of triangles, or the properties that you learned in O level, the angle here is the same as the angle which is here. So for us to get this angle, the second angle theta, we are simply going to get 180 degrees minus this angle for us to get the remaining angle theta. So for the first quadrant, we got theta to be 22.42 degrees. And then for the second quadrant, to get this angle from the positive x-axis to this region, we simply get 180 degrees minus 22.42. And then you're going to end up with 157.58 degrees. Now remember, I told you angles must be to 2 decimal places. After getting both of the angles, we make a conclusion that therefore the value of theta is going to be 22.42 degrees and also 157.58 degrees. Now let's look at solution B. So for solution B, cos theta is equal to 0.6667. So let's first get the angle in the first quadrant. Also for this expression, you are seeing that cos theta is positive. So we have to first draw our quadrant and we see which regions is theta positive, or is the value of cos positive. So first is going to be in the first quadrant, and this is where we get our value of theta. Then also the other quadrant where cos is positive is the fourth quadrant. So we have to measure the angle from the positive x-axis going to the fourth quadrant. And we say that to do that, we are going to get 360 minus the angle which is present at this point. So let's look at the solution for that. So for us to get the angle in the first quadrant, we simply take cos this side. So it's going to be arc cos of 0.6667. So we get 48.19 degrees. So you're going to say that since cos theta is positive, then theta is going to lie in the first and the fourth quadrant according to this sketch I've elaborated for you. So remember that with the first angle that you have got is 48.19 degrees. Remember, I've told you angles must be to 2 decimal places. So after getting that, you refer back to the expression that you had. Our value of cos theta was a positive answer. So to get the second angle, we measure angle starting from the positive x-axis, and then we rotate to the quadrant where also cos is positive. So cos is positive in the fourth quadrant. because that's where it lies. So for us to get an angle here, we say that we are going to get 360 minus theta according to the summary made in the previous video. So it's going to be 360 minus 48.19 degrees. So we are going to come and say that for the first quadrant, theta is going to be this, and to get the angle in the fourth quadrant, where cos theta is also positive, we are going to have 360 minus 48.19 degrees. So we are going to end up with 311.81 degrees. So after that, we make a conclusion that theta is 48.19 degrees and also 311.81 degrees. Now we proceed to part C. I hope that is understood. So part C, you're also seeing that the expression of tan theta is giving us a positive answer. So it means that we get an angle first in the first quadrant simply because in the first quadrant, every trig identity is positive. We also get an angle in the third quadrant because the third quadrant is where tan is also positive. So the first angle is going to be coming from here to there, and then the second angle is going to be going from the positive x-axis up to the third quadrant. So let's look at the solution for that. So first, in the first quadrant, after taking tan this side, we simply say it's going to be arctan of 0.5733. So you're going to get 29.83 degrees. The answer must be to 2 decimal places because we measure angles in 2 decimal places. So the other quadrant where tan is positive is the third quadrant. So let's also get the angle which is going to be present in this region. So our first angle, we got it as 29.83 degrees. So the other quadrant where tan is positive, remember we measure angle starting from the positive x-axis. So we come from here to the third quadrant where tan is positive. And to do this, remember that we made a table and we said that to get that angle is going to be 180 plus theta, whereby theta is going to be the angle that you get at first. So you're going to say that the angle which is going to be present in the third quadrant, theta, is going to be the same as 180 plus 29.83 degrees. So you're going to end up with 209.83 degrees as your second angle. So we make a conclusion that, therefore, for this positive range, the value of theta is going to be 10.29.83 degrees and also 209.83 degrees. Now for question 2, we are going to be solving in case the values of sine, the values of cos, and the values of tan give us negative angles or give us negative expressions. We are also going to be measuring for positive ranges, whereby we are going to be starting from the positive x-axis going anti-clockwise. So remember, for this, since these expressions are giving us negative answers, that means that we need quadrants from which these expressions are going to be negative. So sine is positive in the first quadrant, so we don't need it. It's also positive in the second quadrant, so we don't need an angle there. But sine is negative in the third quadrant, and it's also negative in the fourth quadrant. That means that we are going to measure an angle starting from the positive x-axis, going to the third quadrant. We also measure an angle starting from the positive x-axis, going to the fourth quadrant. And you are going to do the same thing to part B and part C. Now let's first look at the solution for part A. So looking at that solution, now remember that we don't need the negative. The negative on the value of the sine simply shows us that we are going to pick our angles from regions where sine is going to be negative. And according to the explanations that we have made, we have said that sine is going to be negative in the third quadrant and also is going to be negative in the fourth quadrant. And we are measuring angles starting from the positive x-axis. So the first angle is going to be this, and the next angle is going to be this. But remember that the first step is to get the angle which is present in the first quadrant, but we don't need it. So after getting this angle, we are going to use it to get the angles that we need, which is going to be the angle present in this quadrant and also the angle which is going to be present in the fourth quadrant. So with that, let's get the angle which is present in the first quadrant. So we do that simply by saying arcsine of the positive value of the angle of the expression you're having. So arcsine of 0.3814 is going to give us 22.42 degrees. the answer must be, or the angle must be to 2 decimal places. So with that, you're going to say that since sine theta is negative, then theta is going to lie in the third and the fourth quadrant, according to what I've explained. Simply because in the first quadrant, sine gives us an expression which is positive, and also in the first quadrant. So we don't need these two quadrants because our expression of sine was negative. So we need to pick angles from regions where sine is going to be negative. So since our first angle was 22.42, for us to get an angle from here to here, we need to get 180 plus theta, and our theta was 22.42 degrees. We also get the angle in the fourth quadrant by simply saying 360 minus theta, and our theta is 22.42 degrees. So you're going to come and say this. Therefore, for the third quadrant, the first angle is going to be 180 plus 22.42. And the first angle is going to be 202.42 degrees. And angle in the fourth quadrant, we get it by saying 360 minus theta. So it's going to be 360 minus 22.42 degrees. And that's going to give us 337.58 degrees. So you're going to make a conclusion that therefore, the values or the angle of theta is going to be 202.42, and the other angle is going to be 337.58 degrees. So now we are going to do the same thing with our part B. So first we eliminate the negative and we get the angle which is going to be present in the first quadrant. And then we identify the quadrants where the expression of cos is going to be negative. So cos is positive in the first quadrant and in the fourth quadrant. So we are going to eliminate these quadrants. We should not pick any angle which is present in these areas. So that means that the angles that you are going to be needing are going to be from this area where cos is negative, and also in the area of tan where cos is negative. We measure angles starting from the positive x-axis. So one is going to be coming from here to here. This is going to be our first angle, and then our second angle is going to be coming from the positive x-axis to this third quadrant. So that's how we are going to get our angles. So first we need to first get the value of theta. Theta is always in the first quadrant. So to do that, you're going to say that for the first quadrant angle, our angle theta is going to be the same as arc cos of 0.6667. So you get 48.19 degrees. You make sure that your angle is to 2 decimal places. So with that, we say that since cos theta is negative, then it's going to lie in the second, the angle theta is going to lie in the second and third quadrant. So we need to find angles that are present in this quadrant, and we say that to get the angle which is present in the second quadrant, we simply get 180 minus theta, or minus the angle you get in the first quadrant. And to get angles in this quadrant, we made a summary, and we said that this is going to be 180 plus theta. So you're going to come and say that for the second quadrant, or for the first angle, it's going to be 180 minus theta, which is the same as 48.19 degrees. And you're going to end up with, if you put it in the calculator, you're going to end up with 131.81 degrees. And then for the third quadrant, theta is going to be 180 plus theta, which is 48.19 degrees. 180 plus 48.19 degrees, and you're going to end up with 228.19 degrees. So you make a conclusion that therefore for this range, for the positive range of theta lying between 0 degrees and 360 degrees, the value of theta is going to be the same as 131.81 degrees and also 228.19 degrees. So looking at part C, tan theta is equal to negative 0.5733. So that means that tan, the value of expression of tan, is giving us a negative answer. So we look for regions where tan is negative. So remember, tan lies in the third quadrant. That means that tan is positive in the third quadrant and also in the first quadrant. So for us to get the angles we need are going to come from where tan theta, the angles of theta where the expression of tan is negative, they are going to come from the second quadrant, and also where sine is positive and tan is negative, and also the other angle is going to come from the fourth quadrant, where also tan is negative. So we are going to measure an angle from the positive x-axis to the second quadrant. We also measure an angle from the positive x-axis to the fourth quadrant. So to get an angle in the second quadrant, we say that this is going to be 180 minus theta, or 180 minus the angle that you get in the first quadrant. And to get the angle in the fourth quadrant is going to be 180, or it's going to be 360 minus theta. We made a summary of that in the previous video. So now let's get to work. So you're going to say that the angle which is going to be present in the first quadrant, for that you're going to get theta. When you're getting theta, you eliminate the negative on your expression. We don't put negatives when we are determining the angle. So it's going to be arctan of 0.5733, and you're going to get 29.83 degrees. So we are going to make a statement that since tan theta is negative, then theta is going to lie in the second and in the fourth quadrant. And then you make our sketch that the first angle is going to be from the second quadrant and the other angle is going to be from the fourth quadrant. We measure angles starting from the positive x-axis. So we get the angle from the second quadrant as 180 minus theta, which is the same as 180 minus 29.83 degrees. So the first angle is going to be 150.17 degrees. And then to get the second angle is going to be coming from the fourth quadrant. The expression for finding angle in the fourth quadrant is going to be 360 minus theta. So it's going to be 360 minus 29.83 degrees. And this is going to give us 330.17 degrees. So make a conclusion that therefore, for theta to lie between the range of 0 and 360 degrees, our value of theta is going to be of two angles. The first angle is going to be 150.17 degrees, and the second angle is going to be 330.17 degrees. Remember, angles must be two decimal places. So now we are going to look at example 3 or question 3, where we look at an angle that's a bit advanced. So here we are being given that sine angle of theta minus 30 degrees is equal to a positive expression of 0.3814. Now here we don't do anything before we get the angle that lies in the first quadrant. So for this, we don't do anything to the angle. You just cross your trig identity onto the other side of the equal sign. And then after, you deal with the brackets by making theta the subject. So since we have already explained all this, how to get all these angles, because they are the same examples. So to get the angle in the first quadrant is going to be arcsine of the expression of the answer. You do not touch the angle. So here the first quadrant is going to be 22.42 degrees. So after getting the angle in the first quadrant, remember that you should only tamper with the brackets after getting the angles. So that means that the first angle that you have got is 22.42 degrees. So since the expression of sine which they gave us is positive, we have to get two angles. The first from the region where all trig identities are positive, and the second from a region where sine or all expressions of sine are positive. So one is going to be 180 minus theta, and the other one is going to be 22.42. So for the first quadrant, our angle is going to be equal to 22.42 degrees. Now that's where we temper with this bracket and we make theta the subject. So we are going to take 30 degrees this side, and if it crosses the equal sign, it becomes 22.42, then plus 30 degrees to get you 52.42 degrees. Now we also get the second angle and we equate it to this bracket, which was our angle initially. So now remember, to get the angle in the second quadrant, we say 180 minus theta. So it's going to be 180 minus 22.42 degrees. And then later we equate it to the expression of the angle that we had in our question. And then we make theta the subject by taking the 30 degrees aside. So if you subtract 180 minus 22.42, you're going to end up with 157.58. And if you take negative 30 this side, it becomes plus 30 degrees. So the second angle is going to be 187.58 degrees. So I make a conclusion that therefore for theta to be ranging from 0 degrees to 360 degrees, the angles are going to be 52.42 degrees and also 187.58 degrees. Now let's look at part B. So part B, you're going to repeat the same procedure. You don't tamper with the angle first. You simply get the angle in the first quadrant by taking cos on the other side. So it's going to be a cos of 0.6667, which is the same as 48.19 degrees. Remember, we say that angles must always be rounded to 2 decimal places. Now we look for, since the expression was positive, we first get the two angles of that cos expression. So cos is positive in the first quadrant and it's also positive in the fourth quadrant. So the first quadrant is 48.19 degrees. The second quadrant is going to be 360 minus 48.19 degrees. So after getting those two angles, we equate them to the expression of the angle that was given in the question, which is theta plus 45 degrees. So for the first angle, since we had already got the first angle, we get our expression of the angle which was given in the question, and then we equate it to our first angle. And then we make theta the subject by taking this one the other side. So it's going to be theta to be equal to 48.19 minus 45, which is going to give us 3.19 degrees. Also, we had already got the angle in the fourth quadrant, and we get it by saying 360 minus theta, which is the same as 360 minus 48.19, and it's going to be the same as 311.81. So making theta the subject for this bracket, we take 45 this side. So it becomes theta to be the same as 311.81 minus 45. And the final answer is going to be 266.81 degrees. The actual answer for angles must be to 2 decimal places. So we make a conclusion that, therefore, for theta to lie between 0 degrees and 360 degrees, the two angles must be 3.19 degrees and also 266.81 degrees. And that was the final answer. Now we do the same to the third expression. So since we have understood, let's be quick for this one. So we get the angle in the first quadrant, and then we get the two angles. So this is the first angle. We get the other two angles where tan is positive. So remember that tan is positive in the first quadrant, which you have already got, and also in the third quadrant, which is the same as 180 plus theta. After getting these two angles, we equate them to the angle, or to the expression of the angle which was given in the question, to obtain the required angles. So to get the angle in the first quadrant, we had already got it. To get the angle in the third quadrant, is going to be 180 plus the angle in the first quadrant. So after that, we equate our given angle in the expression to those very angles, and then we make theta the subject in either of them. So we shall make a conclusion that, therefore, the values of theta for those partial expressions is going to be 89.83 degrees and also 269.83 degrees. I hope you have understood that. And if you're understanding, make sure that you like the video so that it gets wider to a student like you seeking for the same knowledge. For any issues, we are going to leave them in the comment section to be addressed in the next tutorials. Now lastly, for this video, you're going to look at this item. So for this item, you're solving the equation sine of this angle to be equal to negative root of 3 divided by 2 for values ranging from 0 to 360 degrees. So this is telling us that the expression of sine is coming from a region where the angles of sine are coming from a region where sine is negative, simply because our answer is negative. And what are those regions? So sine is positive in the first quadrant, which you don't need, and also in the second quadrant, which you don't need. Therefore, that means that we have to get this angle given in the question and equate them to the angles that you are going to find in the third quadrant where sine is negative, and also equate it to the angle we get from the fourth quadrant where also sine is negative. But you have to first find the angle in the first quadrant, which is theta. So to do that, we first eliminate the negative and we take sine this side. So it's going to be arc sine of root of 3 divided by 2. And after putting everything in the calculator, you're going to end up with the angle in the first quadrant to be 60 degrees. So we find the angle in the third quadrant. And in the third quadrant, find an angle there, starting from the positive x-axis, is going to be the same as 180 plus theta, which is the same as 180 plus 60 degrees. And then we equate it to this expression given, the expression of the angle given the item. So we also do the same for this fourth quadrant, according to this sketch. So for the third quadrant, we say that to get an angle there, we are going to say 180 plus theta, which is the same as 180 plus 60 degrees. So we get the angle which is given in the item, in the question, and then we equate it to that particular angle that you have got. So notice that 180 plus 60 is the same as 240. So to get theta, we simply make theta the subject. So you take 20 this side. So it's going to be 240 minus 20 degrees. And the first angle that you are going to get is going to be 220 degrees. So you also do the same to the fourth quadrant. Theta plus 20 must be equal to 360 minus theta. And your theta is 60 degrees. So if you subtract 360 minus 60, you're going to end up with 300. So if you make theta the subject here, we take 20 this side. So it's going to be 300 minus 20 to get you 280 degrees. So we make a conclusion that, therefore, for the range of theta lying between 0 degrees and 360 degrees, the two values of our angles are going to be 220 degrees and also 280 degrees. Now for this case, we didn't have any decimal places. If you don't have decimal places, you do not indicate them. Don't say 0.00. So that was it for this video as a whole. Alright, so we meet in the next video where we are going to be looking at the relation between Pythagoras theorem together with the trigonometric identities, sine squared plus cos squared theta to be equal to 1. So don't miss that out in the next video. Make sure that you like the video and then forward it to your colleagues who are seeking for the same knowledge. Help each other to improve. So see you in the next session.